subject of mechanical system design. I am Professor A.P. Godke, Assistant Professor in SND College of Engineering and Research Center, Babulgaon, Yeola. Now today we will discuss about some important topic related with the cylinder. So the concept we are going to see is nothing but autofrettege. Now this concept or process is mainly related with the cylinder. So the autofrettege is the process of pre-stressing the cylinder before using it into the service. Means whenever the cylinder is manufactured, before using that cylinder in actual service, the pre-stressing process is carried out. That process is called as autofrettege. It is used in case of high pressure cylinders and gun barrels. Means the cylinders which are subjected to high pressure. In such application, the autofrettege is done. When the cylinder is subjected to internal pressure, we know the circumferential stresses at the inner surface limits the pressure capacity of the cylinder. In the pre-stressing process, residual stress, compressive stresses are developed at the inner surface. When the cylinder is loaded in service, the residual compressive stresses at the inner surface begins to decrease. So, and becomes zero and finally becomes tensile as the pressure is gradually increased. So, as the pressure is going to increase, that residual stresses are going to decrease and finally become zero. There are three methods of presetting of the cylinders. They are as follows. First is a compound cylinder consists of two concentric cylinders with the outer cylinder shrunk onto the inner one. This induces a compressive stress in the inner surface. The compound cylinder is extensively used in practice. This is the first method of pre-stressing. We have to use two concentric cylinders with the outer cylinder strung on into the inner one. So this will reduce the compressive stresses in the inner cylinder. Second method consists of overloading the cylinder before it is put into the service. The overloading pressure is adjusted in such a way that a portion of the cylinder near the inner diameter is subjected to distress in the plastic range, while the outer portion is still in the elastic range when the pressure is released. The outer portion contracts, exerting pressure on the inner portion, and it undergoes the permanent deformation. So this will reduce the residual compressive stress at the inner cylinder. So this is the second step or method used in the pre-stressing, that is the autofrettege. Third one is the wire under the tensioner is closely wound around the cylinder, which results in residual compressive stresses. So these are the three methods that are used under the autofrettege. Next, so first method, that is nothing but how the compound cylinder is used as a pre-stressing for autofrettege. We can see in the diagram also. The inner diameter of the jacket is slightly smaller than the outer diameter of the cylinder. When the jacket is heated, it expands sufficiently to move over the cylinder. As the jacket cools, it tends to contract onto the inner cylinder, which induces residual compressive stresses. So there is a shrinkage pressure P between the cylinder and the jacket. The pressure P tends to contract the cylinder and expands the jacket. See here in diagram you can clearly see the cylinder jacket is provided which is the first method of the pre-stressing or autofrettege. Second, next point is the gasket joints are provided to avoid the leakage. So the gasket is a device used to create and maintain the barrier against the transfer of fluid across the mating surfaces of a mechanical assembly. So that is the main objective of the gasket, is to avoid the leakages. So there are two types of gaskets are used generally in the assembly. One is a metallic gasket and second one is a non-metallic gasket. So the gasket material which is made up of metals is a metallic gasket, and the gasket are made up of non-metallic material are non-metallic gaskets. So in metallic gasket it consists of sheets of lead, copper or aluminum material. Mechanical gaskets or metallic gaskets are used for high temperature and high pressure applications. Then non-metallic gaskets are made up of asbestos, cork, rubber or plastic material. These are applicable for some medium pressure or low pressure applications. So you can see here two types of diagram are shown here. So this black portion or black component is considered as a gasket. Second one is a non-metallic gasket, which is a asbestos, cork, rubber or plastic. So here you can observe this black component is considered as a gasket. Next one is a unfired pressure vessel. So unfired pressure vessel is defined as a vessel or a pipeline for carrying, storing or receiving the steam, gases or liquid at pressure above the atmospheric pressure. Such pressure vessels are designed according to the national and international codes IS 28252 1969. Code for unfired pressure vessel. The Indian Standard Code for pressure vessel gives the design procedure for welded pressure vessel that are made up of a ferrous material. So here in diagram you can clearly observe the one pressure vessel design. So you can see the different sheets. By joining the different sheets, the pressure vessel is made by welding. Then it is made up of a metal material, maybe cast steel or mild steel or alloy steel. Depending on the design pressure, the material may be the brittle or ductile material. Then the type of welded joints used in the four categories: category A, B, C and category D. So here you can observe for joining at particular location, the various categories of the welded joints are used. So four categories are there: category A, category B, category C and category D. Now this portion of the pressure vessel is called as a shell. Then this portion is called as a enclosure. This is also enclosure. Then these are some nozzles, outlet, inlets are provided for the pressure vessel. Then this is the head of the pressure vessel. So category A, the longitudinal welded joints within the main shell communicating the chambers and nozzles. Circumferential joints connecting the enclosures to the main shell are comes under the category A. So here you can observe this is for example, this is the shell portion. So here you can see the first A category welded joint is used. Then again for here also you can see for enclosure, from shell to enclosure, the welded joint for the sheets are used as a. Then communication for the nozzle and shell is also jointed by the some category A joints. Then second category B is the circumferential welded joints in the main shell communicating the chamber or nozzles. Then third category is category C. Welded joints connecting the flanges and flat heads to the main shell. Then category D is the welded joint connecting the communicating chambers and nozzle to the main shell. So here same categories are used for the various regions or areas for the pressure vessel. Then types of welded joints and their efficiencies for the welding. So first welded joint used is the double welded butt joint. Second one is a single welded butt joint with a backing strip. Third one is a single welded butt joint without backing strip. Here in this diagram you can observe here backing strip is provided to strengthen the joint. Here single welded butt joint without backing the strip. Means here depending on the loading application or pressure, the backing strip with the single welded butt joint is used. Then weld joint efficiency considered for a double welded butt joint if it is fully radiographed 1, for spot radiograph is 0.85 and not radiograph it is 0.70. For single welded butt joint with a backing strip it is 0.9, then for spot radiograph it is 0.80 and for not radiograph it is 0.65. Then third category is the C, for single welded butt joint without backing strip. So fully radiographic weld joint efficiency is not there. Spot radiography is also not there, but 0.60 is considered for not radiographic conditions efficiency. Next, design of the enclosures, that is the heads and ends for the pressure vessel. So if the form heads are different form heads are used as an enclosure for cylindrical pressure vessel. So hemispherical head will be there. Then semi-elliptical, elliptoidal or ellipsoidal head is also there. Then third one is the dome shape head also there. So for that head, the thickness is calculated for this is pi ri upon 2 times sigma t efficiency minus 0.2 pi. So depending on that, plus CA means corrosion allowance for each and every material if there is some amount of carbon is there or a percentage of carbon is there in the material used, then corrosion allowance we are going to consider. Means if a brittle material like cast iron or cast steel is there, then we are going to consider this corrosion allowance, and if mild steel is there, then low carbon steel material is there, then we does not consider the corrosion allowance. So here for this hemispherical head we are considering the thickness as a pi ri upon this term 2 times sigma t, that is a tangential stress efficiency, and minus 0.2 of internal pressure. Ri is the radius of the head, di is the diameter of internal diameter, and do is the external diameter. Similarly, the efficiency is calculated for semi-elliptical and hemispherical dome shaped head. So here T is equal to this formula is used, plus corrosion allowance is considered, and for third one T is equal to 0.885 PIL. Also here length is considered, which is very important parameter. Then another parameters are same, and plus corrosion allowance we will get the design of the enclosures. Then openings in the pressure vessels. The openings are provided in the pressure vessels. These could be an inlet and outlet pipe connections, manhole or handhole, and connections for pressure gauges, temperature gauges, and safety valves. The openings are circular, elliptical, or apron. Such openings are designed by the area compensation method. So when the opening is cut in the pressure vessel, an area is removed from the shell, it must be reinforced by an equal amount of area near the opening. The area removed should be equal to the area added. The area is added by providing the reinforcing pad in the form of an annular circular plate around the opening. So here in diagram also it is shown. Area removed and area added. So this is called as a openings and enforcement while the openings provided in the pressure vessel. So thank you for watching the pressure vessel topic.